Hey guys, this is Mr. Betts, and we're going to take a look today at solving one-step equations using addition and subtraction. We're going to start off by looking at our algebra tiles that we were using earlier this week and just review that very quickly. Remember, when we're using algebra tiles, we have integer tiles, which represent +1 and -1. We also have variable tiles, which represent x and -x. Our ultimate goal is to figure out what 1x is equal to by isolating our variable and getting rid or canceling out everything on the same side of the equation as the variable. So let's go ahead and model this real fast. On the left-hand side of the equation, on the left-hand side of the line, we have an x tile and 3 positive integer tiles. And that represents x plus 3. On the right-hand side of our equation, we have -5, so we use our negative integer tiles to represent -5. So I'm going to pull over 1, 2, 3, 4, and 5 negative integer tiles. Now we have our equation set up. We have x plus 3 on the left-hand side, which matches our algebraic notation, and we have -5. We have 5 red tiles on the right-hand side. Now to solve these equations, we need to, again, isolate the x. So we need to cancel out, we need to get rid of the +3, the 3 yellow tiles on the left-hand side. And we do that by creating 0 pairs. So we want to cancel out 3 yellow tiles, 3 positive integer tiles. So we're going to pull 1, 2, 3 negative integer tiles, 1 for each of our yellow tiles. And to keep our equation balanced, we're going to do the same thing on the other side. So we're going to pull 1, 2, 3 -1 integer tiles on the right-hand side also. Now everything is balanced. We've done the same steps to the left and right-hand side of the equation. Now at this point, we are creating our 0 pairs. On the left-hand side, we have 1, 2, 3 sets of 0 pairs. So all of these are going to disappear and make 3 0 pairs. On the right-hand side, we don't have any 0 pairs, so I'm just going to organize these a little bit. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 negative integer tiles, which means that our final answer for this problem is x equals -8. There's our final answer. So that's how we use the algebra tiles to model these equations. And remember, when you're done, you want to check your answer. So we would go ahead and just make sure that we have the correct answer. So we do a quick check. We rewrite the equation. X plus 3 equals -5. We believe our answer is -8, so we have -8 plus 3 equals -5. -8 plus 3 is -5, and that's what we were hoping for on the right-hand side of the equation, so we know that our answer is correct. Now, if we go in and try a few of these with all algebraic notation, we don't have our tiles anymore. A lot of you guys still like to draw the line down the middle, which is perfectly fine. But now, instead of adding and subtracting tiles to both sides, we're going to show integers. So, we have x plus 3. What we're going to do is we're going to cancel out our addition with subtraction. So addition and subtraction are called inverse operations. So we've got x plus 3. We are going to subtract 3 from both sides of this equation. At this point, we look at 3 minus 3 and we say, okay, that is 0. So all of these tiles or all of these numbers, these integers on the left-hand side are going to cancel out, and we're left with x equals. Now on this side, we have -5 minus 3. Remember, when we were doing our integer operations, we were changing our subtractions into addition and showing ourselves that we have 2 negative numbers. 2 negative numbers, when we add or subtract, is still going to be negative. When we have the same signs like this, we just add up the total number of integers. So we have -8, and again, that's our final answer, which is what we got with the tiles. Again, we go through and check, and we have x plus 3 equals -5. We substitute negative 8 in for x, and we have negative 5 on this side, negative 5 on the right-hand side, which shows us that our answer is correct. When you're checking, this is the step you're looking for. You're looking for the same number on both sides. You're looking for what's called a true statement. Another example with subtraction now. You have two options here. Again, we're going to draw our line down the middle, and we have subtraction, so the inverse operation of subtraction is addition. So a lot of you guys are just adding 15 to both sides. Okay, and that's perfectly fine if you understand what's happening there. If you don't understand what's going on there, then you can change your subtraction into addition, add the opposite, and show yourself that to cancel out these negative 15, this negative 15 on the left, you are still going to add 15. The step is exactly the same, and about half of you do it one way or the other. At this point, you're hoping that you're getting rid of all your integers on the left-hand side, which we are. We're left with x equals, now negative 30 plus 15. We have different signs, so that means we have to find the difference between these two numbers. The difference between 30 and 15 is 15 by doing some subtraction. And we have more negatives than positives, so our final answer is negative 15. Go ahead and check. If you write the original equation out, we have x minus 15 equals negative 30. We now believe that x is negative 15, so we write negative 15 minus 15 equals negative 30. A lot of you guys add the opposite here, which is awesome because that helps you out with your integer operations. We can see on this side we have 15 negatives, 15 more negatives. We have 30 negatives on the left-hand side. We have negative 30 on the right-hand side, and we know that our answer is correct. Lots of little things that can happen with all of the integers and the positive, negatives, and subtractions, so be really careful. This is the level of work that I'm looking for, so make sure that you guys are showing your work and checking your answer when you're done. We've got 4 practice problems for you guys here, so you can go through and check your understanding with each of these. I will post the answers to these so you guys can check on the cabinets if you get these finished, or ask me any questions that you might have. So good luck on these 4, and we'll see you in class.